Alrighty, so we have part A. Oops. Okay, so we have part A. We want to find the value of m. Now, we're given information about the gradients here. So what I'm going to do is I'm going to use the coordinates a and b because, well, we know the gradient of the line AB is equal to, well, it's rise over run, and we've got a and b, so it's 1 minus 1 is what I would say if it wasn't 1 minus 4 over 1 minus 1, and then that'll give you minus 3 on 2. Cool. So that's the gradient. But we also know that the gradient of AB is equal to minus 3m. So that means we have, well, minus 3m is equal to minus 3 on 2. Now if we do some arithmetic, these 3's will cancel, so we'll get m is equal to 1 on 2. We want to find the coordinate c, which we'll denote by xy. Now we know that the line AC, the gradient, is rise on run. Now the coordinate for c, we're just going to do y, and then we've got y minus, well, what's the coordinate for a again? It's 1, and then x minus 1. So this is the gradient of the line AC, and we also know that that is equal to 3m, and we know m is equal to a half, so it'll be 3 on 2. Cool. Then what we'll do is we're going to clean this up a little bit. So we'll get y minus 1 times by 2 is equal to 3x minus 1. And then we'll expand that out to y minus 2 is equal to 3x minus 3. And let's bring the y's and the x's on the same side. Perfect. Now what we're going to do is we're going to call this equation 1. And then we can do the same thing for line BC. So again, we know that B has coordinate minus, 4. That's x minus 1. And that'll give us, and we know that's also equal to m, which is equal to half. Cool. Cool. So then we got y minus 4 on x plus 1 is equal to 1/2. We'll just do the same thing we did before. Expand it out. And we'll bring the x's and y's to the same side. Beautiful. And you might be able to see what we're going to do next. We are going to solve these simultaneous equations. What I'm going to do is I'm going to use the elimination method. I'm going to say, let's do 1 minus 2. So we'll get 2y minus 3x minus 2y minus x is equal to minus 1 minus 9. Okay, and then the y's will cancel out. We'll get minus 3x plus x is equal to minus 10. So we get minus 2x is equal to minus 10. Divide all of that by minus 2. And you get x is equal to 5. We're nearly there. And then we'll sub back into, let's sub into 2. So we'll get 2y minus 5 is equal to, because we're subbing it in there, 2y minus 5 is equal to 9. So we get 2y is equal to 14, which means y, and we'll divide by 2. So we get y is equal to 7. Perfect. So that means we know that C has coordinates 5, 7. Okay, and the final part, part C, we want to show that AC is equal to 2AB. Okay, so, well, the distance we're looking at here, the distance of the line AC is, we just use our distance formula, which is the square root, and then here we are. Okay. So let's figure out AC first. So we've got the square root, and we know that the coordinate here is 5, so we'll chuck 5 in there, and we know for A it's 1. So we'll square that, and then we've got 7 here, and then again for A it is 1. Perfect. And then what we're going to do is we'll just calculate this. So we get 36, oopsies. So 5 minus 1 is 4, 4 squared is 16, plus 7 minus 1, which is 6, and 6 squared is 36. So you'll get the square root of 52. Now we're going to simplify this a little bit. We know that 52 is just equal to 4 times 13. And then we can use our rules, and we can take the 4 out front. Well, we know the square root of 4 is 2. Okay, so this is AC. Great. Now let's look at AB. So for AB, well, we've got 1 for the A coordinate minus 1 squared, and then again 1 minus 4 squared. Cool. So then we've got 1 minus minus 1, which is 2. So 2 squared is 4, plus 1 minus 4 is minus 3, minus 3 squared is 9. And you get the square root of 13. So that means A and AB is the square root of 13. Now we can see that AC is equal to 2 times by AB, because AC is 2 square root 13 and AB is the square root of 13. And voila, all good.